Hello, boys and girls and Cougar parents. Let's take a look at that study guide again. We just need to make sure that we know how to perform all these different operations on exponents as well as simplify them. Test coming up tomorrow. Now let's kind of put it all together. We're going to be simplifying the following expressions, and they're going to go from simple to very complex. If I have 6 to the negative first power, that negative exponent is telling me that I need to do repeated division. In this case, it's not really that repeated, but it is going to be 1 over 6 to the first power, which is really just 1/6. Okay, next I have 9 divided by a to the negative 7th power times b to the 6th power. Well, the 9 is going to hang up in the numerator for the time being. My a to the negative 7th power, I have to convert that to a fraction, which is 1 over a to the 7th power times b to the 6th power. Okay, now this is where it gets a little funky. When I'm taking 9 and I'm dividing it by a fraction. Anytime I divide anything by a fraction, what I'm really doing is I'm multiplying by its reciprocal. So I need to take 9 times the reciprocal of 1 over a to the 7th power, which is going to be a to the 7th power over 1 times, and this b, this is actually 1, this b to the 6th power needs to stay in the denominator, so that stays down there. And when I multiply this all the way through, I'm going to get 9 times a to the 7th power over b to the 6th power. I just multiplied straight across all my numerators and then all my denominators. And if you feel better about it, I can put 9 over 1 just so you see what's going on there. 1 times 1 times 1 is b to the 6th power. There are no terms, no common terms that I can combine or simplify in any way. And let's look at our third example. We have 7x to the negative 8th power times 6x to the 3rd power. Okay, well, I can combine some like terms here. 7 times 6 is 42, and x to the negative 8th power times x to the 3rd power is going to be x to the negative 8th plus 3rd power, which will be 42 times x, a negative 8, and a plus 3 will be a negative 5. Okay, I've got a negative exponent here, which says I need to change that to a fraction, which is going to be 1 over x to the 5th power. I bring down my 42. So it's 42 times that, which is going to be 42 over x to the 5th power. Let's go to our last page. Let's look at numbers 10 and 14 on the last page. I know these look a little scary, especially 14, but they're really not. Just like in life, when you have big problems, you can't tackle it all at once. You just have to break it down into smaller issues or problems and deal with it one step at a time. Okay, well, here I have 3x y to the 3rd power, and I'm raising this entire product to the 2nd power, so I'm going to do some distribution here, and then when I'm done with that, I'm going to multiply it by the product of x, y, and I'm raising all that to the 6th power. Well, let's distribute. There's nothing inside the parentheses that we can combine or simplify, so what I'm going to be doing is I'm going to be distributing the 2nd power to all the terms inside the parentheses. Okay, so first of all, that would be 3 to the 2nd power times x to the 2nd power, because this is really x to the 1st power, so I'm multiplying. When I raise an exponent to a higher exponent, that's what's going on. And then I have y times y to the 3 times 2, which will give me 6th power. Okay, I'm done distributing that. Now I need to distribute my 6th exponent to both of these terms, and that will just give me x to the 6th power times y to the 6th power. Let's see if we have any like terms. Well, my coefficient 3 is all by its lonesome, but I do have two x's that I can combine. X to the 2nd power times x to the 6th power is going to be x to the 2 plus 6 power, which will give me 8. and then y to the 6th power times y to the 6th power will give me y to the 12th power. And that's that. Next, okay, scary, scary, not really. Once again, combine like terms. I see, I have m to the negative 6th power divided by m to the negative 13th power, which I know is m to the negative 6th power minus a negative 13th power. Okay, when I divide an exponent by an exponent, I subtract the denominator's exponent from the numerator's exponent. So I have a negative 6 minus a negative 16, which a double negative is going to turn into a positive. And then over here, times n to the negative 3rd power minus the negative 1st power, which again is a double negative, so it's going to turn into a positive. Well, let's look at this. A negative 6 plus a 13 is going to give me m to the 7th power. Okay, those two exponents, when I subtract a negative exponent, it becomes addition, and I'm going to have a positive 7. And then n, I have over here, I've got n to the negative 3rd minus a negative 1, which is really plus 1. So a negative 3 plus 1 is going to give me a negative 2. I've got a negative exponent here, so I'm not done with this. I will bring down my m to the 7th power, and then my n to the negative 7th power will be expressed as a fraction, 1 over n to the 2nd power. Let's clean this up, and I end up getting m to the 7th power over n to the 2nd power. And that is my final answer for that problem. Well, I hope that was helpful. Tomorrow we will go over the study guide some more and get ready for the test. See ya.